implications and statements. And today, we will introduce a more powerful proof technique called induction. So before we introduce what induction is, we have to talk about something called predicate. A predicate is essentially a statement that takes in some inputs. The inputs could be natural numbers, some expressions, real numbers, or integers, and it will output true or false. So in the case of inductions, we will assume that the input we're taking in is natural number. So today, we will cover simple induction. And the goal here is to prove that P of n is true for all n in natural number. We will start off with the base case, which essentially says we want to show that P of 1 is true. Then we'll move on to the key step called induction hypothesis, which basically says let's assume P of k is true for some k in natural number. And we want to prove that P of k plus 1 is true. This can also be written as P of k implies P of k plus 1 using implications. And this is good enough for the proof once we can prove this. And the reason is, let's say we want to verify P of 571 is true. We can simply go from P of 1 implies P of 2 implies P of 3 all the way to P of 571 because we have already showed that given any P of k plus 1 must be true. So this works for any arbitrary n value. Now that we have seen how simple induction works, we're going to try to solve a real problem. In this case, we're given a family tree, and we're trying to make the assumption that you have two distinct parents, and every single family member here also have two distinct parents. So now let's look at what we're trying to prove. We're trying to prove that you have 2 to the power of n parents. So we start off with the base case. We're trying to prove that this statement is true when n is equal to 1. As you can see from the diagram, when n is equal to 1, you indeed have one parent. So the base case is good. Now we move on to the induction hypothesis. Let's assume that you have 2 to the power of k parents, or we could write it as P of k in predicate logic. We want to prove that you have 2 to the power of k plus 1 parents. This is what we're trying to prove for the induction. The one observation we have to make that is important is that each k parent has 2 parents, as you can see here from this diagram with the assumption. Therefore, based on that, we can say that you have 2 times 2 to the power of k, which is equal to 2 to the power of k plus 1 parents. And the reason is that we know that you have 2 to the power of k number of k parents. And therefore, by this logic, we know that P of k plus 1 holds. Thus completes our proof.
Amazing.
Woo! Yeah, that was good.